This is Drax in North Yorkshire, the single largest power station in Britain. It generates a whopping 7% of our entire electricity needs. It consumes coal like it's going out of fashion, which it may well be. But not here, because Drax gobbles up to 36,000 tonnes every day, ferried in by 140 trains a week and stored in vast mountains. It looks a bit like the snow-capped Austrian Alps in negative, and these mounds need to be constantly compacted to remove trapped air, or the whole lot can spontaneously burst into flames. Which I assume is why the camera crew decided to film me from half a mile away. Nice of them to tell me. So before my career ends in an unexpected blaze of glory, I've decided to hot-foot it up the side of one of the massive digging machines to meet operator Mick French, whose job is to keep the furnaces inside the plant constantly fed with coal.
Hello here, Mick.
Hi.
Don't want to interrupt you. You carry on.
That's okay.
This is amazing. I can't believe I'm not on a ship.
No.
It's so big, isn't it?
It is big.
Do you know how many tons it scoops out?
It's taking out about 2,000 tonne an hour.
2,000 tons an hour?
2,000 tonnes an hour.
Wow. Well, do you think it's possible for me to actually have a go? I mean, this has got to be the biggest digger I'm ever going to have a go on.
I can't see why not.
Much to my surprise, Mick doesn't bat an eyelid when I ask if I can have a go. And encouraged by his nonchalance, I settle in the seat and prepare to waggle the controls. I mean, how difficult can it be?
Right.
So if you just push it forward for about maybe 3 seconds or
Push it that
4
way.
seconds. Yeah.
Am I going a bit too fast there?
Yeah, you are a bit there.
Sorry.
It's okay, because we're not too deep.
No.
Power crazed, I realised I now have the ability to move mountains with the simple flick of the wrist. The controls allowing me to swing the bucket wheel arm left or right and drive the entire machine along the tracks.
Yeah.
Ah! It's not fast. That's actually quite reassuring. I was worried it was going to spin round.
As the Leviathan lumbers along on rails, the spinning bucket head chomps away at the coal pile and feeds it to a conveyor which whisks it into the plant.
You're doing well there. Don't be doing too well.
No.
After 10 minutes carving up the landscape, I'm just getting a taste for power when I'm interrupted by a surprise phone call.
Oh.
Hello, bucket wheel. Okay, Paul, thank you. He's got enough coal.
Oh, is he?
Yeah.
He doesn't want any more?
No. So you've done your job.
I've done my job.
Yeah.
I've done really well.
Suitably chuffed with my coal digging exploits, I follow the coal inside to find out what happens to it next. It's only then that I begin to realise just how ridiculously huge this place is, sprawled across a whopping 1,800 acres.
I mean, the scale of everything here is breathtaking. Not only that, it's shaking. I'm standing on a solid concrete floor and it's going like this. Look at the ladder. I mean, it's terrifying. The noise and the vibration is totally overwhelming.
I expected to see the coal from the heap outside being fed directly into the furnaces. But it turns out to make it burn better, it's first given a bit of a dusting up by being pulverised to pieces.
Now, when the coal comes in off the conveyor belt from outside, it's taken into these giant mills. There's 60 of them here, 60 mills, and each one has 10 incredibly heavy balls inside. These balls weigh a ton and a half each, and they spin round and round inside the mill, turning the coal into a fine powder like flour.
But if you tried shoving this powdered coal onto your living room fire, you'd suddenly find yourself without a roof and sitting in your neighbour's garden, because the coal is now more like an explosive gas. It's fed into 6 huge boilers. Each one is as high as a 15-storey office block and weighs 4,000 tonnes. Together, they burn up 560 kilos of the powdered coal every second. But the immense heat isn't turned straight into electricity. Instead, running through the inside of each boiler is a staggering 480 kilometres of steel piping. Into one end goes water, and out of the other comes high-pressure steam so hot that if you tried to sauna in it, you'd be instantly vaporised.
So, like Casey Jones, we've turned coal into steam. Join me after the break to find out how we turn steam into electricity.
Heat, which has turned water to steam. But of course we left the steam age behind years ago, so the next task is to turn the steam into electricity. That happens here in the mind-bogglingly massive turbine hall. At 418 metres long, almost 55 metres wide and over 30 metres high, this place is the size of a cathedral. It houses 6 massive turbine units, which are fed by the steam from the boilers. As the steam flows through the turbines, it spins the blades at 3,000 RPM. But unlike the steam age, when that would have been used to turn the wheels of an engine or a factory machine, instead it drives the generators, which create up to 4 million kilowatts of electricity. But most of the time, we don't need all that much power. So they've built this impressive control room. Here they ensure that minute by minute, just the right amount of power is being generated to meet the country's needs. So you can switch on your telly and watch fab shows like How Do They Do It without the lights going out. It looks a bit like the bridge of the Starship Enterprise. In fact, it's so swish up here, I've been asked to wear space-age blue bags on my feet to meet the man in charge, Peter Emery.
Now, this has been such an exciting day. When I knew we were coming here today, I was half expecting, because it's coal-powered, some big Victorian machines, rust and muck everywhere, but it's very, very high-tech, isn't it?
We control all the units from here, not only the boiler operation, but the electrical generation, and also we're in constant communication with the national grid to make sure that we can optimise our units and keep the grid balanced.
So if they want a bit more electricity, you can
turn it up or down. Yes, well, in fact, each one of the panel guys has a lady that comes on a special contact, and she tells us up a bit or down a bit.
Since Drax began supplying electricity back in the early 70s, they've made quite a few changes to reduce the environmental impact from burning coal. These days, before the waste gases escape from the massive 259-metre-high chimney, they're first treated with limestone, which removes nearly all of the nasty sulphur dioxide. Not only that, but amazingly almost all the other waste, such as the 1.4 million tonnes of coal ash, is recycled to make products for the construction industry. Even so, I can't help wondering about the massive bell-shaped towers, which appear to be belching thick smoke into the Yorkshire sky.
You know, I always thought what came out of the top of these giant chimneys was smoke, but there's 2 things wrong with that. 1, they're not chimneys, they're cooling towers, and 2, it's not smoke, it's steam.
But this is not the steam used to drive the turbines. This steam is formed when the towers cool the water they use to stop the turbines overheating. Drax may sound like an evil villain from James Bond and look like the set of a futuristic science fiction movie, but there's no denying it's a truly extraordinary piece of engineering, bigger and noisier than just about anywhere else I've ever been.
We all take electricity so much for granted, it's just like some sort of magic in the wall. But when you see where it comes from, how it's generated, I shall never again plug in a kettle without feeling a little bit of awe and excitement. It's just so majestic here. It actually makes the pyramids look a little bit dull.